So I just want to expose you guys to the way your starting observation table in research should be written down, since you would be working on the research activity. I thought that this lab makes a very nice way of what's in the literature. And if there's any errors or issues, how do we go about fixing that? Or if we have to run the reaction on a different scale, how do we figure that out? So over here you have your starting material, which is acetanilide. And our purpose is to basically remove this acidic hydrogen using a mild base, K2CO3, and replace that with the substituent C2H5. We will learn about this Williamson-Ether synthesis more in chapter 18, which is coming pretty soon, but we are doing the lab ahead of time. Okay, so if you look at the procedure, it says there that you're supposed to use 1.38 grams or so. Since reactions always work in molar quantities, it's a good idea to determine the moles or millimoles, which is what we are doing here. So we have basically divided the 1.38 by 151, and that gave us the 0.0085. Now, if we consider the substrate to be one equivalent, this equivalent is nothing but molar equivalent. So this is the ratio of all of your reactants. What is the ratio for those? So if I consider that to be 1 for the acetanilide, all the others will be the ratios, and we will get that by dividing. Right now I'm looking that as millimole, but we can totally have that as mole in this particular case. So let's write here mole or millimole, because if it's a really small scale reaction, then you would be dealing with millimoles, but here it's moles. So I was just trying to tell you that the ratio of these moles is what gives you the equivalence. So in our reaction conditions in your lab manual, it says that you are supposed to use 2.5 grams of the K2CO3. If you divide that by the 138, you should end up getting 0.018. And so if I now divide the 0.018 by 0.0085, I get that ratio number to be 2.17. The book also tells you that you would add 0.5 grams of the material or 1 milliliter of the ethyl iodide. There is a typo in here, not calculation, but rather typo there. Recognize that that cannot be true, because the density that they have given for ethyl iodide is 1.97 grams per milliliter. So if you would have taken 0.5 grams and you took 1 milliliter, then the density should be 0.5 grams per milliliter, right? So their numbers are off. It really should be 1 gram is what they would have taken, and which amounted to about 0.5 milliliters. So if you go with the 1 gram and you divide it by the 156 grams per mole, the value in terms of moles comes out to be 0.0064. And again, if you do the math for that, the equivalents come out to be 0.7529. Notice now that you have only about 0.7529 more equivalents of the ethyl iodide for every 1 equivalent of the acetanilide. Do you think that our ethyl iodide is enough for this reaction to take place? Obviously not, right? So you will have some unreacted acetanilide which will stay behind in your reaction mix, and you will have to figure a way out to remove that. And so if you go through the procedure, it says at some point of time that you have to give it a wash with sodium hydroxide. That is what is happening there, because sodium hydroxide is potent enough to get rid of the acidic hydrogen and solubilize that acetanilide so that it is removed from your organic layer. Anyway, also know that ethyl iodide, it has a boiling point somewhere in the 60s, I think. and the solvent in this case, which is 2-butanone, has a boiling point of about 79, I think. So if that boiling point is true, you are heating this reaction mix above the boiling point of the ethyl iodide. And so some of that can get lost, even though we have the reflux. And so the cold water jacket is supposed to cool down the drops, but you may lose some of the material, and so your yields can be low. Well, one way that you can increase the yield is by increasing the equivalence a bit. From 0.75, you could always use up to about point, I mean, you can use 1 as well, but know that any reaction can sometimes get stuck in an equilibrium, and if there is leftover ethyl iodide, then you don't want to inhale that. It's a toxic chemical, right? So we will try to keep it less than 1, but we will go up to probably about like 0.95 or so. So we'll increase that a little bit. That will be one change that I would want you to make. So going over the scale and how that should look like. I want you to run the reaction in 0.5 grams. That means your moles is going to change. So 0.5 divided by 151. What does that look like? I'm getting a value of 0.0033, and that is equivalent to my full equivalent. So in order to determine the amount of K2CO3 that I need for this scale, it's going to be 0.0033 times 2.17, and that gives me a value of 0.00718. And if I multiply this by the molar mass of K2CO3, which is 138, I get a number 0.9915 grams. That means that if I want to run my reaction on the 0.5 gram scale, I should be using 0.9915 grams of K2CO3. So far, so good. I also asked you to increase the equivalence of the ethyl iodide just a tad bit. So that's about 0.95. So 0.95 times 0.95 times 0.0033. That comes out to be 0.003135. And so we would multiply that times this number times 156, because that's the molar mass of ethyl iodide, and that gives me a value of 0.489 grams. And 0.489 grams, if I divide that number by the density, which is 1.95, you get 250.8. That means 250.8 microliters could be taken to set up this reaction. All right. So your numbers become 0.5 grams of acetanilide is going to react with 0.9915 grams of K2CO3. You will take, since you have decreased the grams now, so you're going to do the concentration difference in case of solvent as well. I believe it was 15 milliliters of the 2-butanone, right? So my solvent could be, since the ratio in terms of moles is about 0.388, my solvent could be approximately around 6 milliliters or so. And that should be plenty. And to that, I'm going to then add just about 250.8 microliters of the ethyl iodide and reflux it for 1 hour. Anytime that it says filter, we will not filter because we will not have enough material. We are just going to allow the unreacted K2CO3 just settle down, and we will decant. So we will only remove the liquid part from your reaction flask and wash it with ether, and that's pretty much it. You would then wash it with 5% sodium hydroxide solution. That will take care of any unreacted acetanilide, if at all. It's a good idea to do a TLC before and after because that will clarify your organic layer. You dry your organic layer, you rotary evaporate it, and you get your final product. And that's the lab.